Hello everybody. So for this video, we are going to be going over quadratic equations. Now with quadratic equations, this is the standard form of a quadratic equation. So we need to notice that it's going to be ax squared plus bx plus c, which is equal to 0. Now since you're in grade 11, okay, you need to understand that quadratic is essentially just the new parabola that you'll be learning how to sketch and how to factorize to find roots and etc, etc. But for now, for example purposes on how to find and solve for x with these types of equations, I'm not going to go into that further detail. If you want to understand this in further detail and you know how to do quadratic equations, look into functions, because this is where it's mostly applied, and I'll be explaining that in the functions videos. But for now, we are going to go over the steps on how to solve for x with quadratic equations. Okay, so first things first, this left hand side, or I guess right hand side, whatever side it would be, must always be 0, right? It must always be equal to 0 on one side, and then on this side you need to have some type of trinomial or binomial or monomial, I don't know, whatever you want. Basically, it must be on the left hand side or the right hand side, just as long as you have something equal to 0, okay? Then this is what you'll be solving. But let's get into an example. Let's do examples, because the examples are going to really help us. This one over here. Example 1. What happens if I say x squared minus 16 is equal to 0? Now first things first, 0 is already on the right hand side, or on one side on its own. But we clearly see that we need to factorize this. And what is this? This is a difference of two squares. And remember that a difference of two squares is if we have x squared minus a squared, then therefore it'll be brackets multiplying each other, where we have x minus a multiplied by x plus a, where clearly x and a are separate, and most of the time the coefficients lie within x, and then a would usually be a constant, but not always. But in this case, let's just use that rule. Clearly we have it in the form of x squared minus, what is the perfect square root for 4? For 16, it's clearly 4 squared. Okay. So therefore we'll use the difference of two squares, which tells us now that we're going to have x minus 4, right, where x is equal to the x over here, and 4 is going to be the a value. And then we multiply it by x plus 4. And that's just equal to 0. Okay. And then from here, what we are going to say is we have x minus 4, and we have x plus 4. But whenever we have all the brackets on the one side of the equation and the 0 on the other side of the equation, we're going to take each and every single bracket and then let it be equal to 0. So that implies to us that we are going to say x minus 4 is equal to 0, and then we're going to say or, and we're going to take the other bracket and we're going to let it be equal to 0 as well, or x plus 4 is equal to 0. Now notice this is going to be something you'll be seeing a lot within quadratic equations. So therefore, what we're going to say is that x minus 4 is equal to 0. We'll just solve for x for each side. We're going to add both sides by 4, such that this cancels, and we have x is equal to positive 4. Or we are going to have the other side, where we minus both sides by 4, because remember we're solving for x, the 4's cancel, therefore x is just equal to minus 4. There we go, there's our answers. Therefore, we see that x is equal to 4, or x is equal to negative 4. In this case, over here. Okay. So yes, this is essentially where we are going to go with this. I'm not going to tell you a whole weird technique or whatnot. This is the most straightforward that we can get. So let's do another example, right? Let's do example 2. I'm going to make a new example. So let's say e.g. number 2. And let's say, for example, I have the following. I'm going to do the exact same thing. X squared minus 16. But here's a catch. Multiplied by x. Now here is where it gets a little bit tricky. this is equal to 0, okay, we need to put that down. But notice something. We don't have a difference of two squares. I mean, sure, this is a perfect square, this is a perfect square, but this is not a perfect square. So that's an issue. So therefore, what we're going to do is we are going to try and see if we can use highest common factors for this one. What is the common factors? Do you notice that x squared can be written as x times x minus 16x can be written as 16 times x? This is equal to 0. Okay. And then from here, notice that we have a common factor, x and x. So we can take out that common factor. And then we can say x multiplied by the remaining, which is x minus 16. So x minus 16, okay, which is equal to 0. Now remember, in the previous example, we took all brackets being equal to 0. But do you notice that we actually have two brackets here? Because x can also be on its own. So we can put that in a bracket as well. So whatever is left out, put it in a bracket. Okay. So therefore that just implies to us that the first bracket can be equal to 0 and the second bracket can be equal to 0 as well. So I'm going to stop with the color coding because the first one had color coding. So let's say x can be equal to 0, or the second bracket can also be equal to 0, which is x minus 16 equals to 0. And then what do you notice? If we solve for x here, we add both sides by 16, then therefore x is equal to positive 16. And then x is also equal to 0. So I would usually recommend writing down, making sure they're always in the same line. But in high school level, they don't really expect you to do that. Just as long as you have x equals to 0 and x equals 16, everything should be great. And your life should be sorted. So those are the two values that can indeed be equal to where the whole trinomial is equal to 0, or the whole polynomial, if you will. Let's do one more example, okay? Just for practice purposes, okay? One more example. Let's do this. Negative 5x squared, and we are going to subtract it by 5x, okay? 5x, and let's add it by 30. And let it be equal to 0. Okay. What are we going to do from here? Now this looks very difficult, but what I want you to take note of is that we have one side being equal to 0, okay? So we don't need to do anything from here. But if it was a case, for example, where one of these terms or whatnot was on that side, you would try and get it to the other side and make sure that the one side is always equal to 0. So make sure that the one side is empty and the other side just has a whole bunch of stuff, if that makes sense. That's the best that I can explain it. So first things first, we have a negative in front of the x squared. Do we like negatives? No, we don't. So let's just try and get rid of that. Let's take out negative as a common factor. If we take out negative as a common factor, we're just left with positive 5x squared. All we do is just flip the signs for every single term if we take out negative as a common factor. So now it's going to be positive 5x, but this positive 30 is going to become negative 30, and that's equal to 0. And then from here, we can divide both sides. Notice this is also just negative 1, really. So we can divide both sides by negative, or just negative 1, if you want to think intuitively. So therefore, negative 1 divided by 0, 0 divided by negative 1 is just 0. So therefore, we can just be left with 5x squared plus 5x minus 30 is just equal to 0. And now notice, we have a coefficient in front of the x squared. Oh, we don't like that. Is there a common factor we can take out? 5, 5, and 30. And notice that 30 can actually be broken down into what? 5 multiplied by 6, right? So therefore, we can take out 5 as a common factor from there. And we'll have 5 multiplied by x squared plus, we take the 5 out, so we're left with x, minus, we're left with 6 from that factor. So therefore, we have 0. And now we can divide both sides by 5, and therefore it'll be 0 divided by 5 on this side. We'll just be left with x squared plus x minus 6. Okay. And then from here, what do we notice? We can factorize. Can we factorize? That's the question. So obviously we can factorize from here. Let's try it, okay? So x squared can be broken up into x times x. And negative 6, or I guess let's just look at 6, not negative 6. We can write it as 3 times 2, or we can write it as 1 times 6. But clearly, what gives us 1? Remember, this is positive 1. What gives us 1? Well, 3 minus 2 gives us 1 out of that combination. So therefore, we'll say x, we'll do the brackets over here. We'll have x and x because of here. And we have 3 and 2 because of this. And then therefore, for the signs, the highest value gets the first operation, which is positive, and the second operation goes to the remaining, but we multiply it by the first operation. So negative and a positive gives you a negative. And now we do our last step, which is therefore saying that this bracket is equal to 0, and this bracket is also equal to 0. So therefore x plus 3 equals to 0. Sorry about that. X plus 3 equals to 0, or x minus 2 is equal to 0. And therefore, when we solve for x, we minus both sides by 3. We get x equals negative 3. Or x, we add both sides by 2. Therefore, we have x equals to 2. And there's our final answer. So therefore, it is that simple. All we need to do is just factorize. That's like the hardest part about everything. And then we'll be able to solve for our x, and life is just simple.